The idea of traveling at the speed of light is an attractive one for sci-fi writers, as the speed of light is an incredible 299,792,458 meters per second. At that speed, you could circle Earth more than 7 times in 1 second. And if humans made it possible, they would finally be able to explore outside our solar system in a very short span of time. So, will it ever be possible for us to travel at light speed? Let's find out. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about a new discovery made to travel faster than light and whether it's actually possible or not. So if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. Albert Einstein's special theory of relativity famously dictates that no known object can travel faster than the speed of light in vacuum. This speed of light makes it unlikely that humans will ever be able to send spacecraft to explore beyond our local area of the Milky Way. However, new research by Eric Lentz at the University of Göttingen suggests a way beyond this limit. The catch is that this scheme requires vast amounts of energy, and it may not be able to propel a spacecraft. The idea of creating a warp bubble is not new. It was first proposed in 1994 by the Mexican physicist Miguel Alcubierre, who dubbed them warp drives in homage to the sci-fi series Star Trek. However, until Lentz's research, it was thought that the only way to produce a warp drive was by generating vast amounts of negative energy, perhaps by using some sort of undiscovered exotic matter, or by manipulating the dark energy. To get around this problem, Lentz constructed an unexplored geometric structure of space-time to derive a new family of solutions to Einstein's general relativity equations called positive energy solutions. Though Lentz's solutions appear to conform to Einstein's general theory of relativity and remove the need to create negative energy, space agencies will not be building warp drives anytime soon, if ever. Part of the reason is that Lentz's positive energy warp drive requires a huge amount of energy. A 100-meter radius spacecraft would require the energy equivalent to hundreds of times the mass of the planet Jupiter, according to Lentz. He added that to be practical, this requirement would have to be reduced by about 30 orders of magnitude to be on par with the output of a modern nuclear fission reactor. Lentz is currently exploring existing energy-saving schemes to see if the energy required can be reduced to practical levels. In addition, any warp drive would also need to overcome several other serious issues. Alcubierre, who regards Lentz's work as a significant development, cites the horizon problem as one of the most pernicious. A warp bubble traveling faster than light cannot be created from inside the bubble, as the leading edge of the bubble would be beyond the reach of a spaceship sitting at its center, he explains. The problem is that you need energy to deform space all the way to the very edge of the bubble, and the ship simply can't put it there. So, let's discuss in detail what actually is a warp drive and how it will help the space industry change its ways of space exploration and travel. A warp drive, or a drive, basically that allows a starship to travel faster than light, is a fictitious superluminal spacecraft propulsion engine that has appeared in science fiction works and is the topic of continuing physics today. This new technology is based on a solution of Einstein's field equations in general relativity, by which a spacecraft could achieve apparent faster-than-light travel if a configurable energy density field lower than that of a vacuum could be created. So, by using this engine, instead of traveling faster than light inside a local reference frame, a spaceship would traverse distances by compressing space in front of it and expanding space behind it, resulting in effective faster-than-light travel. It has been observed that within regular space-time, objects cannot accelerate to the speed of light, so the Alcubierre drive alters space around an item to allow it to reach its target faster than light would in normal space without violating any physical rules. Now, although this new technology is believed to be phenomenal, the notion of space warp has been challenged as illogical. as it has been linked to a number of other rubber science concepts that do not fit into our present knowledge of physics, such as anti-gravity and negative mass. As you obviously know, the cosmos is enormous. So, can we actually build a ship that goes faster than light? Harold White, a National Aeronautics Space Administration scientist and the lead of the Advanced Propulsion Team, was in charge of the space agency's attempts to see if a faster-than-light warp drive is viable. And if so, how can we build one? So, to prove it, Harold created a model and concept for a starship that closely resembles the Enterprise from Star Trek. White directed an interferometer experiment that was intended to assess such an impact at the nanoscale. The data received from this experiment was equivocal, and the scientists highlighted that while a non-zero or non-confirming impact was seen, the difference may have been generated by other factors. In other words, more data was required. However, failure of the experiment does not rule out the possibility of warp bubbles, as it's also conceivable that we're attempting to detect them in an inefficient manner. To explain this phenomenon to the public, White explained in a statement, "Our detailed numerical analysis of our custom Casimir cavities helped us identify a real and manufacturable nano-microstructure that is predicted to generate a negative vacuum energy density, such that it would manifest a real nanoscale warp bubble. Not an analog, but the real thing." So if he is actually correct, White's team has possibly discovered the world's first warp drive. Even so, if scientists had all the materials they needed for the so-called Alcubierre drive, the energy emitted off the space fabric warping spacecraft would be enough to rip planets apart. In addition, White recently told The Debrief, a science and technology magazine, "To my knowledge, this is the first paper in the peer-reviewed literature that proposes a realizable nanostructure that is predicted to manifest a real, albeit humble, warp bubble." White and his team plan to conduct more experiments into the possibility of smaller models to better understand the opportunities of a prospective warp drive. Perhaps the Eagle Works laboratory can take us from science fiction to reality. As he said, "You would anticipate zero pressure outside and zero pressure in the cavity, but what we find when we measure is negative pressure in between the plates. What we're trying to do is explore the quantum vacuum at a fundamental level." In response to Tyson, Musk wrote on Twitter with a persuasive case for sticking to his core business and said, "If we create a city on Mars, Earth-Mars travel will be a powerful forcing function for inventing something like warp drive." So, it's obvious from the tweet that Musk is thinking far off in the future when he will build a city on Mars. So, if humanity wants to travel between stars, people are going to need to travel faster than light. And if humans actually make it possible to build a warp drive, then nothing can stop humanity from beating the galactic speed limit. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.